Calculus, Unit 1, Day 1-2 notes. Our objective is to evaluate, if it exists, the value of a limit from a numerical and graphical approach, including one-sided limits. So when we talk about numerical and graphical approach, usually there's a rule of 4 for limits. Numerical, which means construct a table of values. Graphical, draw a graph. And then the other two, analytical, use algebra or calculus. And then verbal, express in words. And sometimes, well, we'll continue to talk about those as we go. Okay, so we're given the equation of a function graph to the right is f of x equals 2x squared plus 5x minus 3 all over x squared minus 9. The coordinates of the hole in the graph are negative 3, 7, 6. So a couple things we want to look at. So from pre-calculus, we know uh, how to find the horizontal asymptote. And so since our degrees are the same, then the horizontal asymptote just becomes the leading coefficient of the numerator over the leading coefficient of the denominator. So horizontal asymptote is y equals 2, and that's graphed right there. Um, I can find the vertical asymptote. Now we think, hey, where the denominator is 0, but, and again, they told us we have a hole, so I know there's going to be something that cancels out. So let's first factor both the numerator and denominator and see what we get. So when I factor the function, I find out, hey, x plus 3 is a factor in both the numerator and denominator. So since I cancel that out, when x plus 3 equals 0, that's where my hole is going to exist. So that's x equals negative 3, and then I substitute negative 3 back in um, to my simplified function and find out that that's 7 over 6, which is what we got there. So there's my hole, and now let's find out, well, hey, what makes the denominator 0 now? So that's going to be my vertical asymptote. That's going to occur when x minus 3 equals 0 and when x equals 3. So right now I have horizontal asymptote at y equals 2, vertical asymptote at x equals 3, my hole at negative 3, 7, 6. Um, and um, I can find where the y-intercept is. How do I find the y-intercept? I can find when that is when x equals 0. And when x equals 0, I'm going to get positive 1/3. So I get 0, 1/3. And I can see that right there. Okay, so that's some of the stuff we worked on in algebra, uh, pre-calculus. Okay, I could have also looked here, hey, 0, 0, so negative 3 over negative 9, and then the y-intercept is 1/3. All right, so let's look at how we communicated this in pre-calculus and now how we're going to start talking about this with our calculus limit notation. So right below, we're given this form. So when you look at the graph, as x approaches negative infinity, the graph of f of x is approaching 2. Okay, I think we're pretty good at that. Well, in calculus, we're now going to say the limit of the function f of x as x approaches negative infinity is equal to 2. So these mean the same things. Okay, as x approaches positive infinity, look at the picture, it's going to go towards that horizontal asymptote equals 2. So now the limit of the function f of x as x approaches positive infinity, supposed to be infinity symbol, is also equal to 2. Okay, let's look as x approaches negative 3 from the left. That's going towards the hole. I know the graph of the function is going to be approaching 7, 6. So now we say the limit of the function as x approaches, now here's our notation, negative 3, and when we say, instead of saying to the left, we just write from the negative direction. And this is also going to equal 7, 6. And now, as x approaches negative 3 from the right, it's approaching that hole. That's also going to be 7, 6. So the limit of the function as x approaches negative 3 but from the right, which is the positive direction, equals 7, 6. There'll be something we'll talk about later on with that. And now let's look as it approaches 3 from the right. So as I go towards the vertical asymptote, excuse me, 3 from the left, then I'm going to approach negative infinity. Again, just looking at the graph here, as I approach 3 from the left, approaching negative infinity, and then 3 from the right, I'm going to be approaching positive infinity. Let's fill those in. And let's use, so this is the limit of f of x as x approaches positive 3, but from the left, it's going to approach negative infinity. And now we will do limit of the function as x approaches positive 3 from the right, it's going to approach positive infinity. So you've done this in your pre-calculus class. We're now going to start talking about it in calculus with this limit notation. And so let's answer this question. Based on what you've just seen, how might you informally define what the value of a limit represents in terms of a graph? And what we can come up with is the limit of the function f of x as x approaches a. Informally, it's just the y value the graph approaches as x gets closer and closer to a. Obviously, the graph never has, it doesn't have a value at the whole when um, the value is 7, 6, but as I get closer and closer to that negative 3 from both the left and the right, it keeps approaching that value 7, 6, 7 over 6. Okay?